In this video, we're going to continue our discussion in answering the question, what is normal? And specifically, we're going to be considering examples with the standard normal curve. So we'll turn to the following example. Suppose that the average price of gas is $2.25 per gallon with a standard deviation of 7 cents, and we will assume that the price of gas is normally distributed. Now, it's easy to answer questions like the following. Part A. What percent of people paid more than $2.25 for gas? This kind of question is fairly easy to answer. If the average price of gas is $2.25 and we want to know what percentage of people paid more than $2.25 for their gas, then we can assume that 50% of the people paid more than $2.25. But questions like the following are less easy to answer immediately. If a gas station is selected at random, what is the probability that their price for gas is less than $2.15 per gallon? We anticipate that the answer to part B should be something less than 50% because $2.15 is less than the average of $2.25, but how much less than 50%? To answer this question, we rely on the fact that we have said that the price of gas is normally distributed. If the price of gas is normally distributed, then it's going to look something like the following. This is what a normal curve looks like, and we're assuming that our average is $2.25. One thing that we want to keep in mind about normal curves is that the percentage is equal to the area, which is equal to the probability. So if we want to calculate the probability that a gas station has gas for sale at less than, we'll say that this is $2.15 right here, that's the same thing as calculating the area beneath this curve. But rather than mathematically calculating the area beneath this curve, and then when we change up the problems and change up the values, having to calculate the area beneath a different curve, what we do whenever we have examples in which the quantity is normally distributed, we relate everything back to the standard normal curve. Recall that the standard normal curve is the normal curve with an average of 0 and a standard deviation of 1. So instead of calculating the specific area for a specific example, what we do is we relate our curve to the standard normal curve, and then we calculate the area underneath the standard normal curve, which will be the same. Now, how do we calculate the area beneath the standard normal curve? Fortunately, not with a ton of computations. Your textbook should have a chart that looks something like this. This chart, the areas under the standard normal curve chart, will actually give us the area beneath the standard normal curve in increments that are sufficient for the examples we will be doing in this class. And we're going to go through and explain how to use this chart to calculate area so that we can relate it back to our specific examples. So let us return to our example of the price of gas being normally distributed with a standard deviation of an average of 225 and a standard deviation of 7 cents. We'll return to part B eventually, but for right now, let us consider the following different question, part C. What percent of gas stations have a price between $2.25 and $2.32. One thing to note is that this example is specifically chosen where we're looking at the mean, and then 232 is one standard deviation above the mean. So keep that in mind as we move along with regards to our general rules of thumb that we've talked about before. We will answer questions like this in the following 3 steps. First, we will draw a picture. This is critical. Second, we will compute the z-score. And third, we will look up the area, and hence the percent or probability in the table. So let's tackle part C. What percent of gas stations have a price between $2.25 and $2.32? Step 1, let's draw our picture. Remember that we're looking at a standard normal curve. It looks or normal curve, which looks something like this, and our average right now is 225. We want to know the percentage of gas stations with a price between 225 and 232. 232 will be right about here, so that's 232. So when we ask about what percentage of gas stations have a price between there, we're really asking what is the area beneath the curve that we have shaded in the picture. But remember, rather than specifically calculating things for every new example, we relate back to our standard normal curve. And the way we do that is we actually are going to measure the number of standard deviations away from the mean we are. And so that's why in step 2 we calculate the z-score. So the z-score of $2.32 is equal to 232 minus 225 all over our standard deviation of 7 cents. Performing the calculations, we get that this is a z-score of 1. So step 3, we're going to look up this z-score in our table to determine the area. So we pull up our chart, and the first thing to notice about the chart is that the columns come in pairs. We have the z-score number, and then this capital A, this column right here, represents the area beneath the curve. Now take into account that it's actually only representing the area beneath the curve from your average up to that z-score. So if we ever wanted to find the number in the tail, we've got to change our calculations a little bit at the end, but keep in mind that it's representing the area between the average and the z-score value. So we had a z-score value of 1, so we scan our columns, and that will be the out of the pair, the columns on the left. We scan our columns until we find where a z-score of 1 is, and that is right above the post-it note right here. We have a z-score of 1 leads to an area of 0.341. So a z-score of 1 led to an area of 0.341. Now, what does that area mean? Remember, the area is equal to the percent, which is equal to the probability, but we have to remember to multiply this by 100 to really get the percentage, and so we have then that it's 34.1% of gas stations have a price of gas between 225 and 232, because the area here is 34.1% of the area beneath the curve. So let's now return to answer part B. What is the probability that a randomly selected gas station has a price less than $2.15 per gallon? And we'll do so with a clean piece of paper. So step 1, we're going to draw our normal curve so that we understand the area that we're actually trying to find. And this is my normal curve. Here's my average of $2.25, and I want to know what percent of gas stations, or what is the probability that a gas station would have a price less than $2.15. We want to know basically the area beneath this portion of the curve that we have shaded there. So step 2 then is to calculate the z-score. So the z-score of 215 is going to be, again, our specific value of 215 minus our average of 225 over 7 cents. If you plug that into your calculator and round it, you should get approximately negative 1.43. I'm using 2 decimal places of accuracy because that's what our chart has, but obviously you use whatever you have with your chart. And we say, okay, so now we do step 3 and we look it up in our chart, but all of our z-score values are positive. So what do we do with the fact that we have a negative z-score? Fortunately, we use the fact that the normal curves are symmetric about the average. So the area on the left-hand side is actually going to be equal to the equivalent area on the right-hand side. So if I take a z-score of, negative 1.43, and I instead consider a z-score of 1.43, so the absolute value of that, the area I get will be the same. So instead of negative 1.43, we're actually going to use a z-score of 1.43. Let's move on to step 3 then of using the chart and looking up the area. And so we whip out our chart and we look for 1.43. Remember, it's going to be the left of the 2 columns if you have something like this, and we identify it. Oh, here it is right here in the middle of the page, and we notice it has a corresponding area of 42.4. So area equals 42.4%. So that's the answer, right? No, that's not the answer. Remember what our standard normal table curve gives us. recall again that it gives us the area between your average and the z-score. So if I look at my standard normal curve, or just the normal curve in general, with a z-score of 1.43, I have 42.4% appearing between the average and that z-score. But notice that's not at all what we wanted. What we wanted was not the area between that value and the average, but what was in the tail. So I have to consider the fact that this is not what I want. I want this area right here. What do? Remember, this is our average. So to the right of my average will be 50% of the area. So if I have 42.4% here, and overall in the right half I have 50%, then the area for what I want is really 50 minus 42.4%, or that gives us an area of approximately 7.6%. So the answer to our question really is, what is the probability that a randomly selected gas station has a price less than $2.15? The area of this tail is 7.6%, which means the area of this tail is 7.6%. And that is the answer to part B. There were two concepts that we had to implement in order to solve this part of the problem, and I want you to keep those in mind. The first concept that we included was the idea of symmetry. Sometimes we want areas on the left-hand side of the curve, but our chart only gives us stuff on the right-hand side. So even if you get a negative z-score, it's okay. Just make it positive. It'll be fine because of symmetry. The second idea that we implemented here is that of subtraction. I didn't want the area between the average and my z-score. I wanted the area of the tail. And so what I had to do is remember that 50% of the data values are in half of my normal curve, or 50% of the area is in half of the normal curve, and so I took out and subtracted what I didn't want to obtain what I do want. So let's consider another part to this problem. What percent of gas stations have a price between $2.20 and $2.32? Step 1, draw your picture so you know that the areas that you're trying to identify. So again, I draw my normal curve and I write down my average of 225 here. A value of 220 is going to be about here, and $2.32 is approximately here. So what we want to identify is the percentage of gas stations between these two prices, or equivalently, what is the area beneath the curve between $2.20 and $2.32. Observe in this situation that we actually have two pieces that we need to identify, because we have some amount of area to the left of our average. I'll call this area 1, and we have some amount to the right. I'll call that area 2. And we're going to have to solve each of these separately and then add the two pieces together. So just to give us a quick idea of the difference in this problem, here we have area 1. That's what's to the left. That's between our average of 225 and 220. And then we also are going to then add that to the area 2, which is right here. That's to the right of our average. That's between 225, our average, and 232. We actually know this already from part C to the problem. We know that this has an area, I'll say area sub 2, that was equal to 34.1%. So now let's move on to step 2, which is calculating the z-score. Again, because 220 is to the left, I'm going to take the absolute value, and you get for your z-score 0.71. If you look that up in your standard normal table, we obtain an area of 26.1%. So that's step 3. We have an area of 26.1%. That's exactly what we need because it is between the average and our z-score, and that's kind of the wedge right in the middle. That's what we're looking for. So that's great. But remember, we actually need to take and add these two areas together. So I'm going to add a step 4 to this problem, which is kind of really answering the question. I'm going to add together the area from step 2, or the area from area 2 with the area from area 1. So if we add these two together, we get a total of 60.2%, or 60.2% of gas stations have a price between $2.20 and $2.32. This example illustrated a third concept you often have to use, that of addition.